of a circular shaft of 60 mm diameter is running at 150 revolution per minute if the shear stress is not to exceed 50 MPa. So find the power which can be transmitted by the shaft. Okay. First of all, write down the given data for that. So diameter of shaft it is given, D is equal to it is 60 mm. 60 mm. Okay. Then N it is given. So number of revolution it is given. N is equal to it is 150 r.p.m. r.p.m means it is revolution per minute. Okay. And shear stress it is given, that is Fs is equal to shear stress Fs is equal to it is 50 MPa, that is in Newton per mm square. Okay. As per the first of all, we need to calculate the torque for that. So as per the torsion equation, in the relation of shear stress, so T divided by torque divided by IP it is polar moment of inertia, then is equal to shear stress, that is Fs, it is denoted by Fs divided by r. R it is radius. Okay. R it is radius. So radius in it will be in terms of d, it will be d by 2. Okay. So r it is radius. So first of all, we need to calculate the polar moment of inertia. Ip is equal to it is Ixx plus Iyy. Ix plus Iyy. Okay. So we know that Ixx is equal to Iyy, it will be pi d raised to 4 divided by 64. Okay. So for circular section, Ixx is equal to Iyy is equal to it is pi d raised to 4 divided by 64. Pi d raised to 4 divided by 64. Pi d raised to 4 divided by 64. 64. 64. Put all this value in polar moment of inertia equation. So Ip is equal to Ix, it is pi d raised to 4 divided by 64. 64. 64. 64 plus pi d raised to 4 divided by 64 plus pi d raised to 4 divided by 64. Okay. So Iyy it is also pi d raised to 4 divided by 64. So addition of these two, it will be get pi d raised to 4 divided by addition of these two, it will be get pi d raised to 4 divided by 32. 4 divided by 32. 32. Okay. Divided by 32. Okay. So this one it is Ip. So R is equal to it is d by 2. R is equal to it is d by 2. Okay. So now Ip is equal, sorry, put all this value here in equation 1. In torsion equation, T divided by pi d raised to 4 divided by 32. Pi d raised to 4 divided by 32 divided by 32 is equal to Fs divided by d by 2. Fs divided by d by 2. Fs divided by d by 2. Okay. Fs divided by d by 2. Okay. So now T is equal to, write down T is equal to final equation. T is equal to, so this one it will become this side, pi into d raised to 4 divided by 32 divided by 32 into d by 2, it will be 2 by d. will be get 2 by D, 2 by D, 2 by D into Fs, into Fs. So 2 is the 2, 16 to the 32, then this D it will be cancel, it will be get dq, okay? dq. So final equation it will be pi into dq, dq, pi into dq divided by 16, divided by 16 into Fs, into Fs, into Fs. Put all this value in this equation. So we will get the torque value is equal to, so pi into, so D it is 60 mm, 60 raised to 3, 60 raised to 3, 60 raised to 3 divided by 16, 16 into Fs it is, Fs it is 50 MPa, 50 MPa. It will get torque from this relation. So pi into 60 raised to 3 divided by 16 into 50. It will be 2.120, 2.120 into 10 raised to the power 6, 10 raised to the power 6 Newton mm, Newton mm. To convert this value, it is in kilonewton meter, is equal to 2.120 kilonewton meter. Okay, this one it is in. So now we need to calculate the power. Okay, power can transmit. Power is equal to, we need to calculate power. So power is equal to 2 pi nt divided by 60. So this formula 2 into pi, 2 pi n into t, 2 pi nt divided by 60. Can write down directly 2 pi n t, 2 pi n t divided by 60. So this one it is power equation. Okay, 60. So put all this value here. So 2 into pi into n it is revolution per minute, it will be 150 revolution per minute, n it is, and t it is 2.120, 2.120 divided by 60, divided by 60. Okay, divided by 60. It will be get in kilowatt. Okay, if you torque value, if you put it is in kilonewton meter, it will be get watt in kilowatt. Okay, if it is put in T, it is, if you put 10 raised to 6 Newton mm, means Newton in mm, Newton mm, so it will be get in watt. Okay, so 2 into 6 pi into 150 into 2.120 divided by 60. It will be 33.30 kilowatt, 33.30 kilowatt. Okay, so power it will be get in kilowatt. If you put this value in kilonewton meter, torque value, if you put it is in kilonewton meter, it will get kilowatt. Okay, if it is put in Newton mm, it will get only in watt. Okay, so this one it is power transmitted by the